Vultr Object Storage is a scalable solution for storing and accessing large amounts of data as objects. As businesses handle everything from large media files to millions of log entries, the demand for flexible and scalable storage solution has grown dramatically. One size fits all approach often leads to overspending on performance or struggling with bottlenecks. Well, that is exactly where Vultr Object Storage Tiers comes in. With four distinct tiers, you can align your storage performance and cost with the specific needs of your workloads. Hello everyone, I'm Sanskriti Harmak, a developer relations at Vultr, and in today's Tech Talk, we will walk through Vultr Object Storage Tiers, explore key benefits and use cases, and will move on to a hands-on demo where we will interact with Vultr Object Storage with various existing tools. So, without any further ado, let's jump right in. Vultr Object Storage offers a flexible tiered approach to meet a variety of workload needs. You can choose from 4 tiers available. For example, standard for low cost, high availability bulk storage, premium for general purpose workloads with improved throughput, performance for data center level responsiveness with NVMe, and accelerated for high write low latency operations with peak IOPS. All these 4 tiers are fully S3 compatible, so your existing tools and SDKs can just work with no reconfiguration needed. And with HTTPS access and built-in encryption, your data remains protected both at rest and in transit. Let's look at what these tiers bring to the table. You get high throughput and low latency, especially in the performance and accelerated tiers. You can scale as your data grows without worrying about provisioning the capacity in advance. There are granular access controls to manage secure data sharing and isolation. And depending on your needs, the tiers are optimized with NVMe or HDD to balance performance and cost. These capabilities support a wide range of real world use cases. You can host static assets like images, HTML, or JavaScript files for fast website delivery. You can backup and archive large datasets, especially for compliance needs. Please check out our Tech Talk on automating files and data backups with Vultr Object Storage linked above in the info card. Global teams can serve content faster using CDN integration. And you can even store unstructured data like logs, media files, and snapshots at a scale on Vultr Object Storage. Now that we know what Vultr Object Storage tiers offer, let's dive into a practical example. In this demo, we will show how to upload and delete objects using 3 common tools: AWS CLI, Python's Photo 3, and S3 CMD. Whether you are scripting automation or managing your data manually, Vultr's S3 compatible setup makes it easy to plug into your existing workflow. Vultr Object Storage speaks S3 language, so you can use familiar tools to manage your data without changing your data storage plan. To get started, log into Vultr Customer Portal and navigate to Object Storage present under Cloud Storage section on Vultr. Here, click on Add Object Storage to provision a new subscription. The first step is to choose amongst the 4 Vultr Object Storage tiers available. The details of the same were discussed previously in the slides. Go back and check the purpose of each in order to decide which of these tiers best satisfies your workload needs. For this demo, we will be moving forward with Premium tier as it is best suited for general purpose workloads and also provides high throughput. Further, we will choose the nearby location and provide a relevant name to our subscription. Once everything is configured, click on Add Object Storage. This action will launch and activate a fresh Vultr Object Storage subscription on your account. Click on it to open its management page. All the essential S3 credentials are listed in the overview section. For example, hostname, secret key, and access key. In order to view all the S3 related fields, you can check out the configuration file by clicking on this I button. Further, navigate to Bucket section. Buckets are top-level containers to store and organize data files, which are often referred as objects. To provision a new one, you can click on Create Bucket. Now, provide a relevant name to your bucket. If you would like to maintain different versions of the same file, you can enable bucket versioning. Otherwise, the file will be overridden with a new version of the same file. You can also enable write once, read many mode for your bucket, which will ensure that once the object is written in the bucket, it cannot be modified or deleted for a specific interval of time till the object lock functionality is enabled. This will prevent unauthorized access and accidental operations on objects. Once everything is configured, click on Create Bucket. As we can see, a new bucket called Tech Talk Demo Bucket is listed under Bucket section. Now let's provision an Ubuntu server through Vultr Cloud Compute instance. For that, head over to the compute section on Vultr. Here, click on deploy server. Now select your preferred instance type. Although it is not strictly required but often recommended to select the same location as your provisioned Vultr object storage. This will help in optimal performance. Further, select the instance size based on your needs and choose the base operating system, for example Ubuntu 24.10. Also apply an SSH key to be able to access your instance remotely. And if you want, you can also add a firewall group or a startup script. Further, provide a relevant name to your instance. From the additional features, pick the one that is relevant to you. We will be going with a non-root user with limited access for security purposes. That's pretty much it. Click on deploy to launch a fresh Vultr Cloud Compute instance. Now that our instance is up and running, we can switch to the SSH environment to interact with our Vultr Object Storage subscription. Currently, I'm on my workstation where I've SSH'd into the recently deployed Vultr Cloud Compute instance. Let's kick things off with AWS CLI, which is a simple yet powerful tool used for managing your S3 compatible storage. It does not even require much of a configuration. So let's begin with an installation. Now that AWS CLI is successfully installed, let's go ahead and configure it. You can easily fetch the S3 credential values like that of the access key directly from the overview section of your provisioned Vultr Object Storage from the Vultr customer portal. Go ahead and copy that value and paste it here. Similarly, do that for the secret access key. Provide a default region and an output format like JSON, HTML, or TXT. Hit enter. Now our AWS CLI is completely configured with the Vultr Object Storage that we provisioned. Let's go ahead and list the buckets that we have in our subscription. Here we have used an endpoint URL flag to provide the host name of our Vultr Object Storage subscription and used the ls command to list all the buckets present in our subscription. Now let's go ahead and create a simple txt file to upload it to the bucket. Let's hit enter. We are simply echoing a message and storing it in the demo.txt file. Let's verify the presence of this file. As we can see, the demo.txt is present. Let's also see the content that is present inside of it. Now let's simply copy this file in our bucket from our workstation. We have provided the endpoint URL here and used a simple copy command called cp, provided the file name and the path of the bucket. Let's go ahead and hit enter. Here we go. It says that the file that we were trying to upload is successfully uploaded in our bucket. To cross-verify it, let's go back to the Vultr customer portal, and here under buckets, as we can see that there is demo.txt present, which indicates that it is successfully uploaded. Click on this ellipsis icon and click on change access to make this file publicly accessible. Further, copy the URL and open a browser tab. Paste the URL over here. And here we can see the content of our txt file. Let's go ahead and now delete the object that we just uploaded in our bucket. For that, we'll be using a simple command. Everything is similar to the previous commands that we have executed, except for this rm command, which is used to remove the file from the bucket. Let's go ahead and execute this command. And the operation was successful. The txt file is now out of the bucket. Let's list all the contents of the bucket to see if the file is actually deleted or not. And here we go. As we got nothing in the results, it means that there is no content in the bucket and the bucket is back to its initial state, which is being empty. Now let's work with Python's Boto 3 for the programmatic way. This will give you more flexibility to interact with your S3 compatible storage. Let's first verify the Python version that we are using. For this segment, we will be uploading an image file to our bucket. I have already transferred the image file from my local system to this remote system using secure copy command. Let's go ahead and verify its existence. So the image file is present. Now let's create our Python script to perform operations like uploading object to the bucket, listing the contents of the bucket, and deleting an object from the bucket. Here is the code. Firstly, we are creating an S3 Boto 3 client where we are passing the essential S3 credentials like endpoint URL, the access key, as well as the secret access key. And further, we have defined three important functions like upload file to upload an object to the bucket, list objects to list the content of the bucket, and delete file to delete an object from the bucket. In the main function, we have initialized some of the important variables like bucket name, the file path of our image, as well as the object key that we will be referring to throughout our script. Now let's analyze each of our functions. For the upload file function, we have used the upload file object functionality of the S3 client, where we are uploading a file type object to our bucket and also providing a content type so that the image is rendered properly. Once the object is uploaded successfully in the bucket, the print statement will be executed. Then we have the list object function, where we are using the list objects v2 functionality of our S3 client. We are passing bucket name as a parameter and checking if there is any content present inside the bucket. If yes, then all the objects are listed in an unordered list, and if nothing is present inside the bucket, then it means that that particular bucket is empty. Further, for our delete file function, we are passing the bucket name and object key as a parameter and using the delete object functionality of our S3 client. If the delete operation is successful on the object present in the bucket, then this print statement will be executed. Now that we have understood how each of our functions operate, let's go ahead and execute this script. As a first step, we will only be calling upload file and list object functions. Let's save the changes and run our script. The output shows that our image file is successfully uploaded in our bucket. In order to cross-verify that, let's switch to the Vultr customer portal. Here inside our TechTalk demo bucket, you can see that there is an image file called Vultr logo. Let's go ahead and change its permission to make it publicly accessible. And copy the URL. Open a new browser tab and paste the URL. And here we go. The uploaded file is perfectly rendered in the browser. Now let's go back to our terminal and open the script again. And now we will uncomment the function calls for delete file and comment out the upload file function call. Save the changes and execute the script again. Here we go. The file has been successfully deleted from the bucket, and now when we listed the contents of the bucket, we can see that our bucket is empty. Lastly, let's use S3CMD, which is another S3 compatible tool that could be used to interact with your provisioned Vultr Object Storage subscription. Firstly, we will install S3CMD tool to our system. For this segment, we will be uploading a video file to our bucket. I've already transferred the file from my local machine to this remote system, again by using secure copy command. Let's check if we have that file in our system right now. And yes, we have a video file present in our home directory. Let's go ahead and configure S3CMD with our credentials. For configuration, you can use the configuration file present in the overview section of your provisioned Vultr Object Storage subscription and fetch the values directly from there. Now that our credentials are successfully verified by S3CMD, let's go ahead and save these settings. As you can see, there is a .s3cfg file that is stored in our home directory. If you want, you can directly edit this file and update the default configurations to your credentials by referring the values directly from the Vultr customer portal. As you can see, the file is present here in the home directory. Now, let's move forward and list the buckets present in our Vultr Object Storage subscription. As we can see, there is only one bucket that we initially created in our subscription. Let's go ahead and upload our video file to this bucket. Here we are using put command to upload vultr.mp4 directly to our TechTalk demo bucket, where it will be stored as vultrvideo.mp4. We are also passing a new flag, which is ACL, which stands for Access Control List, and it has been set to public, which means that the file that will be uploaded to the bucket will be publicly accessible. This will also generate a public link that we can use to refer to the file, apart from what Vultr will provide us with. So let's go ahead and hit enter, and here we go. The public URL of the object is created. Let's go ahead and copy this URL. Open a fresh browser tab and paste the link over here. And this is the preview of the file that we uploaded. Let's go back to the terminal and delete the uploaded video file. The result shows that the file has been successfully deleted from the bucket. But let's go ahead and cross-verify it. As there was nothing in the output, it indicates that there is no content present inside the bucket. So that's how easy it is to use AWS CLI, Python's Boto 3 and S3CMD to interact with your Vultr Object Storage subscription. To sum it up, Vultr Object Storage gives flexible storage options with clear performance and cost profiles. And with S3 compatibility, it's easier to integrate Vultr into your storage strategy. If you would like to explore further, you can start by picking the tier that best suits your workload and provisioning a bucket either directly from Vultr customer portal or by exercising Vultr API or CLI commands. To make it even easier for you to get started, you can use the custom promo link attached in the description below to receive $250 in free credits on a new account. Thank you so much for being a part of today's Tech Talk. We hope this helped you get most out of Vultr Object Storage.